So I've been wanting to set up some local-only domains for My Homelab that didn't actually require buying a new domain, and the reason for that is actually pretty simple. After you've got a bunch of services up and running in your Homelab, accessing them is kind of a pain. You've got to remember IP addresses, you've got to remember ports, and on top of that, anytime you try to use HTTPS on those services, you end up with those self-signed certificate errors in your browser. And honestly, I finally got sick of clicking through those warnings every single time. So what I wanted was something like sonarr.local or plex.local, clean domains that resolve on my local network with valid HTTPS responses. And I wanted that across all of the devices that I access my services on with no exceptions. Hey, real quick before we get into it, this video is sponsored by Boot.dev. And I actually want to talk about this one because it's genuinely relevant to a lot of us. If you've been in the Homelab space for any amount of time, you've probably picked up bits and pieces of Linux and Docker, maybe some networking, kind of through osmosis, just by doing the thing, spinning up containers, breaking stuff, fixing it, and learning as you go. And honestly, that's a great way to learn, but there's a difference between knowing enough to get your stuff running and actually having the foundational skills that translate to real projects or a career in this space. And Boot.dev is built around closing that gap. It's an interactive platform that teaches you Linux, Docker, Go, AWS, cloud engineering, the hard skills that actually have demand behind them. And I don't mean video lectures that you fall asleep halfway through. I mean hands-on in the browser, actually writing code and doing the work. It's not a boot camp and it's not a passive course site. It's more like if your terminal had a progression system and you actually wanted to keep going. And there's a whole Discord community behind it too. So if you get stuck, you're not just staring at a wall. All of the content is free to read and watch, and a paid membership unlocks the full interactive coding experience, including progress tracking, AI assistance, and the game mechanics that make it actually addictive. And right now, you can get 25% off your first year with my code DBTech at boot.dev, and the link is in the description. So now let's get back to our video. Now, before we get into the solution that we're going to take a look at in this video, I want to show you what we're actually building here because I think it will help put everything in context. So if we jump over to my desktop, here we can see I've got home.local. And if I click here, we can see that home.local, the connection is secure. And if we open that up again, we can see that the certificate for this is valid. On here, I've actually gone through and have rebuilt this recently so that I can go to, say, plex.local. There we go. Plex.local. There we go. Sometimes it takes a little while to resolve, and that's just kind of the nature of the beast. Prowler, I've never actually loaded on this system, so we'll give it a second to see what it does. While that's, oh, there it goes. There is Prowler.local. Again, we've got Sonar, we've got Radar, we've got Dockhand. And these will maybe take a little bit longer to load depending on your DNS configuration, but there is Sonar. Again, connection is secure, certificate is valid. There's Radar, there is Dockhand. Again, all of these have a secure connection with a valid certificate. Now, the one thing I want to show here also is my Vault Warden instance is on password.lan. And we're actually going to talk about exactly why I did that here in just a second. Now that last one, password.lan, I put that in there on purpose because I want to show you that you're not locked into just using .local as your top level domain. You can use .lan or .home or .internal or whatever makes sense for your setup. And we'll talk about why you might want to think about that here in just a minute. So now the question is, how did we get here? Well, let me walk you through that here real quick. My first instinct was to reach for Nginx Proxy Manager. And if you've been hosting or self-hosting for a while, you're probably at least familiar with it. It's got a great UI, it's easy to set up, and it handles reverse proxying really, really well. The problem is, at least in our case, is that NPM wasn't really built with local certificate management in mind. It's designed to work with Let's Encrypt, which means it expects to be able to reach out to an external certificate authority to prove that you own a domain. And that doesn't really work for .local domains because there's no external DNS. These domains only exist on your network. Now, you can get NPM to work with self-signed certs, but then you're kind of back to the same problem with the browser warnings. So Nginx Proxy Manager isn't really the right tool for this specific job. Caddy, on the other hand, has a built-in certificate authority. It can issue and manage its own certs for whatever local domains that you happen to throw at it automatically with no external dependencies. You just distribute its root certificate to your devices once, and after that, every new service you add gets a trusted HTTPS certificate with no additional work. And that's exactly what we need for this setup that we're going to take a look at today. Now, before we get into the setup, I want to talk briefly about domain choice because it actually kind of matters. The .local top-level domain is technically reserved for MDNS, and that's the protocol that lets devices on your network discover each other by name. Things like AirDrop and Bonjour use it. In practice, though, using .local for your HomeLab domains usually works fine, but on some devices, you can run into conflicts where MDNS and your custom DNS may fight over who gets to resolve the domain. If you want to avoid that entirely, .lan is a popular alternative. It's not officially reserved for anything, it doesn't conflict with MDNS, and it works exactly the same way in your setup. Now, I've used both in my HomeLab testing here and haven't had any issues with either one, but it's worth knowing the distinction so that you can make an informed choice for your particular setup. For this setup, you're going to need two things running on your network. First will be AdGuard Home or Pi-hole. Now, either of these will handle our local DNS so that your devices know how to resolve your custom domain names. Second, you're going to need a machine to run Caddy on. Now, I'm running it in a dedicated LXC on Proxmox, but you could just as easily run it on any machine that runs Docker and has ports 80 and 443 available. Now, this part of the video assumes that you already have either AdGuard Home or Pi-hole set up on your network. I'm going to be using AdGuard Home for this, but you can still take this information and kind of translate it over to Pi-hole to make this work for your setup. So I wanted to just put that little disclaimer in there. You will hopefully you've already got these set up on your network for a bit of added security at the DNS level. But if not, go get either AdGuard or Pi-hole set up and then come back and we'll jump into the rest of this. So now what we're going to do is actually take a look at setting up Caddy. What we're going to do here on your LXC or Docker host, we're going to create a directory for Caddy, and then we're going to set up a compose file to get Caddy to run in Docker. Now, this YAML file will have Caddy as the service that's listed. We're going to use the latest Caddy image, though you probably, for security reasons, should probably pin a version, but that's a discussion for a different video. The container name here is Caddy, and a restart policy here is set into unless stopped, which is very common. We've got a network mode of host. We've got volumes for Caddyfile, data, and config, and those are each mapped to the respective locations for their individual volumes inside the container. Now, the network mode host is important here because it lets Caddy bind directly to ports 80 and 443, like we talked about earlier, on the host without any port mapping, which avoids a whole class of networking headaches that you could run into. So we're not going to deploy that Docker compose file just yet because first we need to create a Caddy file. So here is what I've got set up for mine. Now, the global local certs block tells Caddy to use its internal certificate authority for all of the sites here. Then for each service, TLS internal tells Caddy to automatically issue and manage a cert for that domain, and reverse proxy points to the actual service on your network. And then once we've created that, we can save and exit that file, and then we can bring up the Docker Compose file with Docker Compose up-D if you're doing it in command line, or whichever service you happen to be using to manage your Docker Compose files. Now we need to fix the permissions on the data directory so that you can access the files that Caddy creates, and I'll have that command here on the screen. But I'll also have a blog post linked in the video description so that you can copy and paste some of these commands to make it just a little bit easier as we go through this. So one thing I somehow forgot to mention is that anytime you modify the Caddy file where we are now, you'll go ahead and save and exit that file, and then you need to reload the Caddy file. So what we're going to do is pretend that we've made a change here. I'm going to exit the file, and then I'm going to run this docker exec caddy reload the config, specifically the Caddy file. So anytime you edit the Caddy file, you're going to run this command like so, and then we get this letting us know that that Caddy file has been reloaded, and we should have the cert generated for our new local domain. Now, one thing worth covering here is that some services in your home lab, like Proxmox, run their own self-signed certificates. And by default, Caddy will refuse to proxy those because it can't verify them. But you can tell Caddy to skip that verification for specific back ends. One thing to note here is the HTTPS in the reverse proxy address. And also you'll notice a TLS insecure skip verify. This is actually safe in a home lab context because that unverified connection is happening entirely locally on your network, and your browser is still getting a fully trusted cert from Caddy. Now, Caddy generated a root certificate when it first started up, and this is the cert that you need to install on every device that you want to use to access your local domains. Luckily, you only have to do it once per device. Now, here on the screen, you can see the command that we're going to use to actually grab that cert file via PowerShell, at least on Windows, and just make note of where you are in your terminal window so you'll know where you've actually downloaded that file. Once you've downloaded that root.cert file, the next thing we need to do is run a command called certutil, which is built into Windows, so you don't need to install anything. But you do need to make sure that you open PowerShell in an elevated or an administrative command prompt mode so that it can actually make changes to your system. And then all we're going to do is make sure we're in the same directory where we downloaded that root.cert file. We're going to run certutil-addstore-f and then in quotes root and then root.cert, and that will install the certificate on your system that will allow your system to recognize Caddy as a certificate authority and actually use the certs that we want for our domains. Now, Chrome and Edge should automatically trust this cert that we've just installed, but Firefox on Windows maintains its own cert store, so you'll either need to import it manually or go to about config and set security.enterprise_roots.enabled to true to make Firefox use the Windows cert store instead. Now we need to tell our network how to resolve these local domain names. In AdGuard Home, we're going to go to Filters and DNS Rewrites and Add DNS Rewrite. For each service, we're going to add the domain name and point it to the IP address of your Caddy host. Not the service IP address, but the Caddy host IP address. Caddy handles the routing from there. And now that we've done all of that, we can see all of our different .local domains opening without any issues, and with the padlock and the HTTPS, everything working the way we would expect it to work. So we're good to go. Well, we're good for Windows anyway. If you want to install this on Android or iOS, I'll have that in the blog post linked in the video description. So for each service that I want to have a local domain name in my home lab, all I need to do is add a block to the Caddyfile, and then add a DNS rewrite in AdGuard Home, and then reload Caddy with the command that's on screen, or again in the blog post linked in the video description. So that's it. Once we have AdGuard or Pi-hole set up with Caddy, it's just 3 steps. Add a block to the Caddyfile, add a DNS rewrite in AdGuard or Pi-hole, and then reload Caddy. It's really just that simple. So that's the full setup, with AdGuard Home handling your local DNS, Caddy acting as your reverse proxy and certificate authority, and a one-time cert install on each device. You get clean URLs with no ports, padlocks everywhere, and adding a new service only takes about 30 seconds. So I think with all of that said, I'm going to wrap this up. Again, there will be links to the blog in the video description if you want to check that out. I would love to know what you guys think about this, or if you've got a different solution that you use for local domains. But again, thank you guys so much for spending a few minutes of your day with me here today, and I'll talk to you in the next video.